In this video for section 3.6, we're going to be talking about how to standardize variables. The purpose of standardizing variables is to allow us to compare two values that come from different data sets with different means and standard deviations. And to standardize a variable, what we do is calculate something called a z-score. To calculate the z-score, we use this formula right here. Z equals x minus x bar divided by s. Remember that x bar is the mean and s stands for standard deviation. So if we have a z-score that's positive, then that means that our data value is above the mean, and a negative z-score means that our data value is below the mean. And that should make sense because in our calculation we're doing x minus x bar. So if x is the data value, x is larger than x bar, then when we subtract, that's going to be positive. If the data value is less than x bar, then when we subtract, it's going to be negative. And the value of standard deviation always has to be positive. So if we get a z-score of positive 2, that means that our data value is 2 standard deviations above the mean. A z-score of negative 1 means that our data value is 1 standard deviation below the mean. So when we make z-scores, the mean of z is 0, the standard deviation is 1, and z-scores do not have units. So in this example, we have some data from house sales. The average price of a home was $175,000 with a standard deviation of $55,000. The size of the houses averaged 2,100 square feet with a standard deviation of 650 square feet. So the question is, which is more unusual? A house that costs $340,000 or a 5,000 square foot house? So we're going to calculate z-scores in order to compare these two. So the house that costs $340,000, we're going to calculate the z-score for that first. So we're going to use our formula, x minus x bar over s. So our x is the $340,000. The mean for price of house is $175,000. And the standard deviation is $55,000. So then I'm going to do this on my calculator. That would give me a value of 3.0. Now I'm going to calculate the z-score for the 5,000 square foot house. So my x is 5,000. That's my data value. The mean is 2,100. And the standard deviation is 650. So divide by 650. And when I do the math on that, that equals 4.46. So that means that the $340,000 house is 3 standard deviations above the mean. The 5,000 square foot house is 4.46 standard deviations above the mean. So the 5,000 square foot house is further from the mean than the $340,000 house. And so that means that the 5,000 square foot house is more unusual. So the 5,000 square foot house is more unusual because the z-score is further from the mean.